Welcome to the explainer. You know, sometimes in algebra, you hit a problem that just looks like a total dead end. Well, today, we're going to tackle one of those. And what if I told you the solution is actually hiding in plain sight?
So take a look at this. Can this expression actually be factored? I mean, a lot of students, when they see this, their first reaction is, nope, no way, impossible. But it's really not.
Yeah, at first glance, it really does seem impossible. And you know what the real hang-up is for most people? It's those exponents. They just look weird. I mean, how are you supposed to find a common factor between something with an n plus 1 and something with just an n?
But it can be done. And in this explainer, we're going to show you exactly how. So let's dive right in. The best part is, this doesn't require any crazy new math, just a clever way of looking at what's already right in front of us.
So, let's break down why this looks so tricky. The real challenge, right, is figuring out what to do with these two terms when their exponents don't seem to match up in a way that's easy for factoring.
I mean, look at the numbers. We've got a 4 and a 2. Finding a common factor there? Easy. It's 2. But it's the variables, that's c to the n plus 1 and c to the n. That's where it gets confusing. That's what makes finding the greatest common factor, the GCF, feel like a real headache.
Okay, so here's the good news. You are not going to have to learn some brand new, complicated rule to solve this. Nope, we're just going to use two tools that I bet you already have in your algebra toolkit.
First up, we've got to dust off our understanding of the greatest common factor, or GCF, right? This is like step one for almost any factoring problem you're ever going to do.
And the second tool? The product rule for exponents. You totally know this one. It's that rule that says when you multiply powers with the same base, you just add the exponents together. Super fundamental, and as you're about to see, absolutely crucial here.
All right, you ready for the breakthrough? The aha moment? The entire secret to solving this whole thing? It's hidden inside that first term.
Yeah, that little guy right there, c to the power of n plus 1. That's it. That is the entire key. Seriously, everything, and I mean everything, hinges on how we decide to look at that one single piece of the puzzle.
So, let's think about this. Remember that product rule we just talked about? If multiplying two things adds their exponents, what does an exponent with an addition sign in it tell us? How can we use that rule, but in reverse?
And here it is. The crucial insight is that c to the power of n plus 1 is just a different way of writing c to the power of n times c to the power of 1. That's it. They're the exact same thing. Once you see that, the whole problem just cracks wide open.
Okay, so now that we've got that key, let's put it all together and watch how this whole mystery just solves itself step by step. So with our new little trick, we can rewrite both of our original terms. That first term, the 4c to the n plus 1, now we can break it down into its most basic parts. And the second term, well, that one was already pretty simple.
And when you lay them out side by side like this, it becomes so much clearer to see what they actually have in common. All we're doing here is a little visual matchmaking for the factors.
And look at that. It's pretty obvious now, right? They both share a 2, and they both share a c to the n. So, boom, our greatest common factor has to be 2c to the n.
So now, the easy part. We just pull that GCF, that 2c to the n, out front. What's left over from the first term? A 2 and a c. And what about the second term? Well, we pulled the whole thing out, so we have to leave a 1 in its place. And just like that, there's our final factored form.
And you know, it's always a good idea to check your work. If we multiply that 2c to the n back into the parentheses, yep, we get exactly what we started with. It works perfectly. So let's zoom out for a second. What's the big takeaway here? I mean, why does solving one kind of tricky problem like this even matter for your whole math journey? Well, it shows that a problem that seemed totally impossible was unlocked just by creatively applying some fundamental rules. The key to tackling harder stuff isn't always learning more math, it's about getting creative and using the math you already know in new and interesting ways. You know, the person who made the original material we're looking at said it best. The only way to have a lot of tools in algebra is to practice. It's so true. Expanding that mental toolkit comes from just doing problems, tackling all different kinds. That's what builds the skill and the intuition to spot these kinds of hidden connections. And that's the real power here. This isn't just about solving one algebra problem. It's about training your brain to see the familiar in a new light. So my question to you is, what's the next impossible problem you're going to solve?